This video is all about chemical bonds, and it brings us back again to the work that we did during school camp and also the work we were revising just when the fourth term started. Okay, so most of these things will be familiar to you. You can watch the first part of the video just to make sure about the theory again, and then the later part of the video will be application onto exam type questions. And just like in all the other booklets, these questions come from exam papers that I found on the internet, mostly departmental question papers, so they're not necessarily IAB standard, but it does make sure that you understand the basics really well. And this preparation is more than enough for the paper that you are writing this year. Okay, so chemical bonds. To do chemical bonds, we need to go back to our lovely periodic table, and we need to go look at our little gnomes and monsters. So just to start off, let's just put in our little step. And to remind yourself that everything on the left are our metals, and then everything on the right are our non-metals. And hydrogen is also included there. So hydrogen is a little bit confused. He's actually a little monster, but he's pretending to be a gnome. I'm not sure what's up with that. Okay, so let's just make a little summary. We have three types of bonds that we can look at in chemistry. The first one is when only the non-metals bond together. So when you have two or more monsters bonding together, we call that covalent bonding. And we actually have a definition for covalent bonding. So a covalent bond is formed by overlapping orbitals that share a pair of electrons. In this way, both atoms obtain a full outer energy shell. Okay, so in the previous video about atoms, we learned that all atoms will either give away or receive electrons so that they can look like the noble sages. And the noble sages are the only ones that have full energy shells. Okay, so this is the fancy definition for covalent bonds. And when we did the practical with the beads, you actually beautifully saw how those atoms need to overlap so that the electrons can get together. When we have covalent bonding, we form molecules. So the bond is called covalent, but the thing that forms is called a molecule. And we also have a definition for molecules. So molecules are formed when non-metal atoms are covalently bonded. So it sort of says the same thing. On the other side, we have the metals. And obviously when we only have metals that bond together, we call them metallic bonds. And for this exam, I'm not too worried about the definition of metallic bonds. But it is these metallic bonds that allow us to be able to do and make circuits, because the electrons can move around. The last type of bond that we can look at is when a metal and a non-metal come together. So when the gnomes and the monsters come together, then we form ionic bonds. The definition of an ionic bond is ionic bonding occurs between metals, which form positive ions, and non-metals, which form negative ions. And there's a transfer of electrons involved. And the things that are created when we have ionic bonds are called ionic substances or salts. So ionic substances are also known as salts, and they are formed when a metal atom transfers electrons to a non-metal atom. Okay, so the definitions are sort of embedded into each other. Okay, and we are going to look at examples of each of these as we tackle the questions. Now, in the previous video about atoms, I did it differently than what I did with the physics. With the physics, I first read the paper and then I did the long form questions before I did the short form questions. And it made me do the paper much faster. When I did it other way around, the video ended up much longer than I anticipated, because I did the short form questions first and then the long form questions. So these short form questions took me an enormous amount of time to work through. It did, however, make the long form questions go a little bit faster. But with my own experimentation, I have found that it is much better to read the short form questions, then do the long form questions, and then come back and do the short form questions. But play around with it and see what works for you. So for this video, again, I'm going to read the short form questions, and then I'm going to do the long form ones, and then come back to the short form ones. Question 1 is true or false. Metallic bonds form when metal atoms share electrons. Okay, so that's the definition of a metallic bond. Covalent bonds form when non-metals share electrons by overlapping their orbitals. That sounds familiar. Ionic bonding occurs between metals, which form positive ions, and non-metals, which form negative ions. Okay, so we can just maybe double check that these positive and negative ions fit together. Molecules, also known as salts, are formed when a metal atom transfers electrons to a non-metal. So we have a metal that transfers electrons to a non-metal. And then a metal substance is one that forms when a group of atoms has a pool of delocalized electrons that surround a lattice of regularly spaced positive ions. So again, this is the definition of a metallic bond, which is not really important for this paper. Question 2, give one word for bonding that occurs between metals, which forms a positive ions, and non-metals that form negative ions. So I'm just going to write here metals plus non-metals, and they're just asking for one word for. This is the energy needed to remove an electron from an atom of that element in the gas phase, and it increases across a period but decreases across a group. So the energy needed to remove an electron. So this is theory that I will cover with the periodic table again, but I will answer it when we get here. It is applicable to bonding. 2.3 is, it is the ability of an atom to attract electrons, making a bond it is involved in, and it increases across a period and decreases down a group. It's again more periodic table things, but I'll cover it here. The other one is, this is the energy change when an electron is added to an atom. Bonds that form by overlapping orbitals that share a pair of electrons. In this way, both atoms obtain a full outer energy shell. So if you can just draw that there, it's exactly those little circles we made in class with the beads. Which one of the following is the structure correctly linked to the given element? Okay, so now we have lithium, iodine, sulfur, and carbon. So let me go get my trusty periodic table. The first one is lithium, that's Lily, and Lily is a metal, she's over there. Then we have iodine, iodine is over there, so she's a non-metal. We have sulfur, she's also a non-metal, and then we have carbon, that is over there. Okay, and we know from our little summary, the ones on the right will do covalent bondings, and when we have one left, one right, it will be ionic bonding. But I'm not going to answer that question now. Metal X forms a sulfate that looks like that. Which one of the following is a correct formula for the nitrate of X? Now, for this one, you actually need some outside information, and it should have been on a list that you learned either last year or the beginning of this year, and that is the valency of the sulfate ion. So the sulfate ion, SO4, has a charge of -2, okay? And if you know that, and you know that this whole little ionic substance needs to have a total 0 charge, then you can actually work out what the charge is on X. Okay, so let's just do that now. So if we look at the sulfate part, we know the charge is -2. If you didn't know it, you know it now. So the charge is -2, and we have 3 of those. So it means that this whole negative side of the bond has a charge of -6. And we know we always want to end up with a neutral substance, which means if I have 2 X's, then each of the X's need to have a charge of +3. Okay, so +3 times 2 gives me a total charge of +6. So the +6 and the -6 together, they cancel each other out. So I have a neutral bond, a neutral substance. So what this tells me is that X has a charge of +3. But now they're asking me something about nitrate. And this is something else that you need to know. Nitrate has a charge of -1. So if I take X with a charge of 3+, and I want to bond it with nitrate that has a -1 charge, does it make sense that the formula will look like this? Okay, so I didn't look at the answers. They are just going to confuse me. I figured them out myself. This one was quite involved. 3.3 tells us ionic bonds form because of very strong forces of attraction between oppositely charged ions. So that is very true and nicely stated. And now they ask us a couple of things about ionic compounds. And we need to test each of these statements. So they say it's electrically neutral, they have high melting points, they conduct electricity, and are gaseous compounds. And we'll come back and test each of those statements. 3.4, ionic bonding occurs between what? Okay, so just without looking at what they're asking me, from my summary, I know they are formed by metals and non-metals. That is what I know. And now I can test it against the statements that they give me. So it's two non-metals, two metals, a metal and a non-metal, and a metal and a semi-metal. And by starting from what I know, it is easy to see that the answer is C. 3.5, a compound consists of ions X2 plus and Y3 minus. What is the possible formula? This is very much the same as 3.2. So if 3.2 was too involved for you, then first try 3.5. It's a little bit easier. So we have X with a charge of 2 plus, and I have Y with a charge of 3 minus. And the easiest way to remember is just that this number will go down there and that number will come down here. So the bond that will form will be X3, Y2. And the reason why that works, if I look at X3, the charge of X3 will be 3 times 2 plus, which is 6 plus, right? And if I look at Y2, it will be 2 times minus 3, and that is minus 6. And with ionic bonds, we want to end up with a neutral compound. 3.6 is the last one of these questions. When a chemical change occurs, now they're asking us a bunch of stuff. There is no change in the mass, or in the number of atoms, or in the number of molecules. There is no change in the mass or the number of atoms, but there is a change in the number of molecules. And then they keep on playing with words. We'll come back to this later. Okay, question 4. These are the long form questions. We have chlorine gas, and it consists of molecules. And we know that is true because chlorine is a monster, a non-metal. And when non-metals bond together, they form covalent bonds, and then we call those things molecules. So everything that they've said up to here is true. And now they want to know, write down the number of valence electrons. That sort of goes back to the previous video. What is the type of bonding? And then draw the Lewis structure. Okay, so this should be really easy for you guys. So, dear Claudine, we have worked with her so often. She is number 17 in the periodic table. She is in column number 7 and in row number 3. Okay. Now, when we're working with the bonding, the only thing that we are worried about is this number 7. So that's your group number, and that also tells us the number of valence electrons. That is the number of electrons that she has to play with. So the number of the valence electrons is the same as the group number, that is 7. The type of bonding will be covalent because she's a little monster. And now they're asking for the Lewis structure. Now, the Lewis structure will be exactly the same as what we did in class. So you're going to start with chlorine, and she has 7 electrons. So we start 1, 2, 3, 4, 5, 6, 7. And then we have another chlorine. They're only talking about chlorine. So I need someone to help fill this gap that the first chlorine has. Let's make her another color blue. And this chlorine also has 7 valence electrons. So it's 1, 2, 3, 4. And now, just because I know I want these two to overlap, I'm just going to change direction. So it's 5, 6, 7. Okay. And then I know that these 2 electrons, they really want to be together because they want a filled energy shell. This is my rough work. And to redraw it, I'm going to redraw it like this. 1, 2, 3, 4, 5, 6. And then I have that little one. When I redraw this chlorine, I'm just going to make it crosses instead of circles, just so that you can see the difference. Okay, and that is chlorine's Lewis structure. If ever they ask you for the Cooper structure, what you're going to do is you'll take these bonding electrons and just change them into one line. And we always add the non-bonding electrons too. So those we will always show. So I can't remember if chlorine was on our little poster, but if you want to make some notes here, this chlorine gas molecule has one pair of bonding electrons, and that means she has one single bond. And then all these other electrons that I drew in the Cooper structure, it's nice to see them in the Cooper structure. All these other electrons are your non-bonding pairs, and I have 6 of those. So one pair bonding electrons, and that is the same as one single bond, and then we have 6 non-bonding pairs. Question number 5 is about water. Water we also did. She's on your poster. And again, they ask, what is the valence electrons in the hydrogen? What is the valence electrons in the oxygen? What type of bonding? And then draw the Lewis structure. So if we look at hydrogen, hydrogen is number 1 in our periodic table, and is also in row 1 and column 1. So lots of ones. And then we have oxygen. Oxygen is number 8 in my periodic table. She's in group 6 and in row 2. So the number of valence electrons in the hydrogen atom is 1. The number of valence electrons in the oxygen is 6. So those are the group numbers. I think we sort of drilled that in with the previous video. The type of bond, again, they're both blue little monsters. So it's going to be covalent again. And now they ask us for the structure. So let's start with hydrogen first. So there's a hydrogen. She or he has only 1 electron. Let's do oxygen next. Oxygen has 6. So it's 1, 2, 3, 4. I'm going to change direction again. 5, 6. So with these electrons, as long as you don't make 2 next to each other in the same movement, you should be fine. But always go northeast, southwest. So you can change direction, but just do it northeast, southwest, or clockwise, anti-clockwise. And then the other hydrogen I'm going to put here at the bottom. Okay, so just like in class and just like we did with the beads, those 2 electrons are going to come together, and these 2 electrons are going to come together, and now we just need to redraw it in a nice way. And usually what I do is I start with the central atom. So there's my oxygen, and then there's a hydrogen, and there's a hydrogen. And just to show you the non-bonding pairs better, there's my oxygen. And then this is a bonding pair because I have a dot and a cross, so I can change that into one line, a single bond, and then I have another one over there. So now I can see I have 2 bonding pairs. Those are the ones that overlapped, which means I have 2 single bonds, and it also means that the other ones that are left, and those are the 2 pairs of non-bonding electrons. Okay. And that is the Lewis structure of water. So if you don't have it on your poster yet, this is something that you can add. Next one is the atoms of carbon and oxygen. Same story. How many valence electrons in carbon, the valence electrons in oxygen. So I'm just going to come and get oxygen. And if we look at our periodic table, carbon is over there. She's number 6. And carbon is also, she's in group 4 and in period 2. Okay, so when we are busy with the covalent bonding and with our ionic bonding, we are worried about this top number, the group number. That gives us the valence electrons. Okay, so the valence electrons of carbon is 4 because she's in group 4, and the valence electrons of oxygen is 6. And now we draw it again. So this is one of the other bonds that we have on our poster. I am going to put carbon in the middle first. Carbon has 4 electrons, so it's 1, 2, 3, 4. And then I have oxygen, 1, 2, 3, 4. I'm going to change direction, 5, 6. And then the same with this one. 1, 2, 3, 4, 5, 6. Now, because I have drawn these Lewis structures like a gazillion times, I sort of know how the electrons are going to end up. That's why I know how to change direction. It's not wrong if you don't change direction as I did it. It just makes the drawing a little bit easier. Okay, so you're going to draw bubbles around the lone electrons because we know the electrons, please, they want friends, they don't want to be alone. This is what it looks like. And with the little circles that we made in class with the beads, it was beautiful to see how those double bonds were formed. So to draw this properly, I'm going to do carbon in the middle. Now, these electrons aren't very snugly organized at the moment. So what's going to happen is these 2 crosses are going to be pulled together so that the bonds can actually be next to each other. And then the same will happen on the other side. So this will form a linear molecule. Okay, so this is our Lewis structure. and if you want to do the Cooper one, we have 2 double bonds on both sides, and then we have a total of 4 lone pairs. Okay, so 4 pairs of bonding electrons, which is the same as 2 double bonds, and then the non-bonding pairs. Okay, nitrogen. Nitrogen gas exists as a divalent molecule. Divalent means 2. So di means 2. So it just tells us that nitrogen exists as N2. Okay, and it's made up of 2 nitrogens. How many valence electrons? What type of bond? Draw the Lewis structure. Same story. So let's go find nitrogen. Nitrogen is number 7, and he or she is in column 5 and row 2. So the 2 and the 5 we used collectively in our electron diagrams, but when we are worried about the bonding, we only look at the top number, the group number. Okay, so there are 5 valence electrons. This will be a covalent bond again, and they asked you to explain your answer, and I would just write the definition of a covalent bond. So you don't have to think, you just need to remember. And now we draw. So we have 2 nitrogens, and they each will have 5 electrons. So I have 1, 2, 3, 4, 5. And then on this side, I have 1, 2, 3, 4, 5. Okay. And now every single electron will go find a friend on the other side. So those 2 will bond, those 2 will bond, and these 2 will bond. So this one will end up as a triple bond. So those 3 dots of the left-hand nitrogen will be pulled together, and the 3 on the other side will be pulled together, and then it looks like this. Your Cooper structure will be this. So we have 3 pairs of bonding electrons, and that's the same as 1 triple bond, and then we have the 2 non-bonding pairs. Question number 8 we are going to ignore because Word completely destroyed the electron dot structures and I'm not sure what they look like to begin with. But it's the same idea. They ask you how many valence electrons are in Y. So if we take the picture as it is, I see 3 dots, and those are our valence electrons. So it will have 3 valence electrons. And then they ask us to draw the Lewis diagram. The other examples that I gave you are more than enough for the test, and then they ask you to identify X and Y. At question 9, we are changing lanes a little bit, and we are going over to the ionic bonds. Okay, now you can read the words going with question 9, but they're just talking about salt, table salt, basically. And they give you a lot of information that's really not important for the question. So the first one that they ask is, what is the chemical formula of table salt? Now that is again something that you need to know. It would have been on a list that you would have received probably last year. It was a lot of learning work. So it's sodium chloride. What type of bond exists between particles of salt? Now sodium is a little gnome and chlorine is a little monster, and when they come together we form an ionic bond. And then they ask, using a chemical equation, show how the ions are formed. Okay, so we've done this. We're just going to write this in a chemical-ish way. Okay, so we know sodium is in group 1. And because sodium is in group 1, we know that she can turn into sodium 1 plus by giving one of her electrons away. Okay, so sodium is in group 1, which means she has 1 valence electron, and she will give that electron away, and then she will have a positive charge. Chlorine, on the other hand, she has 7 valence electrons already, but she really wants 8, because then she can look like argon, which is the next noble gas in front of her. So chlorine will rather go and look for 1 extra electron somewhere so that she can become Cl-. Okay, and these are the 2 equations that they're looking for. So sodium will have an electron added on the right hand side because she's giving it away, and chlorine will have 1 electron added on the right hand side because she is taking that electron up. And when we balance these 2 equations, which they're not asking for now, but these 2 electrons will cancel out, and what is left is the formula that we need. So sodium plus Cl minus, and then it becomes Na1Cl1, but we don't write the ones. Okay, so that was question 9. Question 10 is again about ionic bonds. Now we have magnesium and chlorine. What is the chemical formula of magnesium chloride? Okay, so we have Maggie. She's in group 2, so she will have a charge of +2. And Claudine, we saw she's in grade 7. She's in group 7, so she will have a negative charge of -1. And by balancing these two, the numbers just go to the opposite corners. So Mg1Cl2. But we don't write the 1. Why do they form ionic bonds? You can just write the definition of an ionic bond. An ionic bond forms between metals and nonmetals. Then 10.3 again is using the chemical equation, show how the ions are formed. So if you didn't understand what just happened there, you have another chance. And if after this one it's still not clear, please let me know. So Maggie is in group 2. So we know that she will want to turn into Maggie 2+, so that she can become a noble sage. And by becoming that noble sage, she gifts her 2 electrons. She gives them away. But chlorine, because chlorine already has 7 electrons, she will rather go and look for 1 extra electron so that she can also become a noble sage. She will just be Cl-. Now, at 10.4, they ask us to show the formation of the salt. Now, we want the electrons to cancel. So we have 2 electrons on the right-hand side of the arrow and only 1 electron on the left-hand side. So what I'm going to do is I'm going to multiply right through with a 2. And when I do that, my electrons can cancel. And then I just write everything that's left on the right-hand side. So it's magnesium 2+ plus 2 Cl-. And when I put that together, I get MgCl2. Okay, so in grade 8 and grade 9, we learned this way of getting to the formula of magnesium chloride. So we just move the charges. Now in grade 10, we actually understand why that happens. So it's sort of the same idea. It's just an explanation of why we can do the things that we do. Now, the last question. I really like this question because it makes the booklet about atoms speak with the booklet about chemical bonding. So it forms a very nice cohesive picture. Now, if you did the previous video with me about atoms, you will know that we have answered all of these except for question 11.8. So I urge you, please go back to the atoms video and find the question that looks similar to this one and make sure that you can answer question 11.1 to 11.7. Right now, I'm only going to worry about question 11.8. Now, if you can't remember what P and Q was, let's go find them. So if we look at P's electrons, she has or he has 2, 4 plus 4 is 8. Okay, so that's number 8. And then Q has, that's 10, 11, 12, that's 17. So we're looking for number 8 and number 17. And we've been working with them all the time. Number 8 is our Olivia and number 17 is Claudine. So we have oxygen. Oxygen is number 8, but we know she's in group 6. That's the magic number that we're working with now. And then chlorine is number 17 in the periodic table, but she's in group 7. Okay, and now we're going to draw the Lewis structures. Now, I'm not exactly sure how this molecule is going to look, so let's just start somewhere. So let's start with oxygen. Oxygen has 6 electrons, 1, 2, 3, 4, 5, 6. And then we have chlorine, which is 1, 2, 3, 4, 5, 6, 7. Okay, so now if I have 1 oxygen and 1 chlorine, I see that these two can overlap. But then this oxygen isn't happy yet because she has this lone electron that doesn't have a friend yet. So let's add another chlorine. 1, 2, 3, 4, 5, 6, 7. Okay, and when I do that, there's another pair that is happy. So if I just tidy this up a little bit, the Lewis structure will look like this. And then obviously you can tidy it up even more by drawing the Cooper structure, where we just take the bonding pairs and change it into a little stripe. Okay, and there we are done. All the other questions were answered in the previous video. The only thing that I want to add here was the Lewis structure, and then we can quickly go back to the short form questions. Okay, let's do the short form questions, and then we are done. Question 1 is metallic bonds form when metal atoms share electrons. Now, if we compare that to question 1.5, that is actually the definition of a metal substance or a metallic bond. They say a metal substance is one that forms when a group of atoms has a pool of delocalized electrons that surround a lattice of regularly spaced positive ions. Now, the problem word that we have here is shared. Are the electrons shared or are they not shared? Now, with each of these chemical bonds, they are very specific in what they do with their electrons. If you look at the covalent bonds, they will share. Those are the little spheres, the little circles that overlapped when we were working with the beads. When we look at ionic bonds, there is a transfer of electrons, exactly the same as what we did with the beads. The yellow one will always give away its electron to the non-metal. What happens with metallic bonds is we have the positive atoms and they have their electrons around them. And what happens when these two atoms come together, the electrons become delocalized, so they sort of lose their space around the atom, and it becomes like it's almost water flowing around the positive ions. Okay, so question 1.1 is false because the electrons aren't shared. Question 1.5 is however true. This is the definition of a metal substance or a metallic bond. Number 1.2 says covalent bonds form when non-metals share electrons by overlapping their orbitals. And that is exactly the definition of a covalent bond. So that is true. Ionic bonding occurs when metals form positive ions and non-metals form negative ions. When metals form positive ions and non-metals form negative ions, and that is true. We especially saw it in these last two examples. So the metal Maggie became magnesium 2+, a positive ion. It's also called a cation. And the non-metal became a negative ion, and that's also called an anion, if you want to use the fancy words. So this is also true. Molecules, also known as salts, are formed when metal atoms transfer electrons to non-metal atoms. Okay, so now we have a problem because we have molecules and salts, and those do not occur in the same definition. Okay, so we have ionic substances that are called salts, and they form when metal atoms transfer electrons to non-metal atoms. So the fact that we have molecules and salts in the same sentence means this is false. And then 1.5 we've already done. Okay, question 2 is give one word for. So this is all the bonding, it's all the definitions that you need to know. So bonding that occurs between metals which form positive ions and non-metals that form negative ions. So when a metal and a non-metal bond together, we have ionic bonds. Now for 2.2, 2.3 and 2.4, we need to look at 3 definitions, and there's not much to understand above just the words that make up the definition. So we have ionization energy. This is the energy needed to remove an electron. So your ionization energy is all about the energy to remove an electron from an atom of that element in the gas phase. Okay, and then it increases across a period and decreases down a group. We'll look at the tendencies of ionization when we do the periodic table. Then we have electron affinity. This is the energy change when an electron is added. And then we have electronegativity, and that is the ability of an atom to attract electrons. Okay, so they're sort of the same, but not really. So the energy needed to remove an electron, that's your ionization energy. The ability of an atom to attract electrons, that would be electronegativity. And then the energy change is the electron affinity. Okay. And then bonds that form by overlapping orbitals that share a pair of electrons. That is your covalent bonds. Right. Okay, only the multiple choice and then we are done. Okay, so for 3.1 we had a list of elements and then they're asking for the structure. if we look at our periodic table, we know that when we work with the blue ones, it is covalent and we form molecules. And when we do both sides of the step, it is ionic and it's ionic substances. So now we just test that what we know to that what they give us. So lithium is covalent. That is not true. She's the wrong color. Covalent is blue. And then iodine is molecular. That can work. Sulfur, ionic. Sulfur can be part of an ionic bond if it bonds with a metal. So I'm not sure about C. And then carbon is metallic. Carbon is not a metal. Carbon is a non-metal. So it's definitely not D. So I would go for B. So C can be true, but I don't have enough information to see that is to say that it is part of an ionic bond. 3.2 I already did when we went through the reading time. So this is the answer that I'm looking for, which means the answer is number C. Okay, so just make sure. I almost said it's A, but it's not A. I have another bracket there. 3.3 I'm just going to skip for a second. If we look at 3.4 we already answered, and then 3.5 I actually already did as well. So it's x3y2. x3y2 is C. Okay, so when there are so many numbers, just check and double check yourself. It's easy to make a mistake. And then we have 3.6. Now, if we look at 3.6, 3.6 will make a little bit more sense after you do the chemical change book where we do the stoichiometry. Now, to answer this, I'm going to write a little formula of a reaction, and the easiest one that I usually do is just hydrogen plus oxygen gives me water. Okay, because I need something to test these statements against. Now I need to balance this, and to do that I need a 2 there and a 2 there. Okay, so 2 hydrogens and 1 oxygen react, and then I have water. If I look on this side, I have 4 hydrogens and 2 oxygens. I have a total of 3 molecules. So I have 2 hydrogens and 1 oxygen molecule. That's where the 3 molecules come from. And if I look at my atoms, I have a total of 6 atoms. All right. And then on this side, I still have 4 hydrogens and 2 oxygens, and that is thanks to my balancing act. I have 2 molecules, and I still have a total of 6 atoms. Okay. And now the other thing that they ask me about the mass. And now there is a law that is similar to the law of conservation of mechanical energy. In chemistry, it is just called the law of conservation of mass. And that is always true. So if I start with 10 grams of whatever, I will end up with 10 grams of whatever. Okay. So there's a law of conservation of mass that is applicable to chemistry. All right, so now we test it. Number A says there is no change in mass. That is true. I have 10 and I will end with 10 always. There is no change in the number of atoms. That is also true because I started with 6 and I ended with 6. I checked that. And now they say there's also not a change in the number of molecules. But for this example, that is not true because I started with 3 molecules and I ended up with 2. Okay, so number A is not working. Number B says there is no change in mass. That is true. It's the law of conservation of mass. Or the number of atoms. That is also true. But there is a change in the number of molecules. Okay, so number B can actually work. Let's just look at the rest. There is no change in mass. That is true. But the number of molecules and the number of atoms change. Okay, so C is also not working because the number of atoms cannot change. They will stay the same for the same reason that our mass remained the same. And then D, the mass, the number of atoms, and the number of molecules all change, and that is false. Okay, so the mass and the number of atoms will always remain the same because of the law of conservation of mass. Okay, and then the last one, 3.3, I'm actually going to leave out. This is about the properties of ionic substances, and I didn't include that in your demarcation, so you do not have to know this. Okay, so chemical bonds, it's really, really easy. There's not much that you need to know, and it's all contained on your amazing poster that you should have finished by Tuesday. So make sure that you know all the definitions. Make sure that you can draw the Lewis diagrams, especially have a look at question 11. It's a really nice representative question of everything that you need to know about atoms and chemical bonds.